Thank you, students. Today I will discuss about critical angle and total internal reflection. We know that when light travels from denser medium to rarer medium, after reflection it goes away from the normal. That means angle of incident is smaller than the angle of refraction. Here it is. This is the incident ray and this is the angle of incident. After reflection, the refracted ray goes here and this is the angle of refraction. Here the angle of refraction is greater than the angle of reflection. If you increase the angle of incidence, then the angle of refraction also increases. Now follow the red light ray. This is and this is. So this is the angle of incident. It increases. So the angle of incident, angle of refraction also increases. After a certain value of angle of incident, or at the certain angle of incidence, say here the green light, after refraction it goes through the plane of separation of the two mediums. That means angle of refraction becomes 90 degree. The angle of incident for which angle of refraction becomes 90 degree, then this angle of incident is known as critical angle. Here the angle of refraction is 90 degree. This is the angle of incident, angle of refraction, and this is the angle of incident. This angle of incident now is known as theta c, or it is known as the critical angle. To get the critical angle, must the light travels from the denser medium to rarer medium. Here, when a ray of light travels from denser medium to rarer medium, the angle of incident for which angle of refraction becomes 90 degree, then the angle of incident is known as critical angle for those two medium. Now, relation between the critical angle and the refractive index. From the Snell's law, we can write down that the light ray travels from the denser medium to rarer medium. So, with the refractive index of rarer medium in respect to denser medium, it will be sin I, that means sin theta c, it is the angle of incident, by sin 90 degree. Sin 90 is 1, so mu r with respect to denser medium is equal to sin theta c. We know that mu 1 2 is equal to mu 2 1. This is there is a formula. So mu rd equal to 1 by mu dr and equal to sin theta. So if you reverse, then you get refractive index of denser medium with respect to rarer medium is equal to 1 by sin theta. This is the relation between the refractive index of the denser medium with the critical angle. If the rarer medium is air, rarer medium means this is the rarer medium at which the light gets refracted. This is the rarer medium. If the rarer medium is air, then rarer medium is air. So the refractive index of denser medium is called, it is the absolute refractive index of the denser medium. So the refractive index, absolute refractive index of the denser medium is equal to 1 by sin theta c, or sin theta c equal to 1 by refractive index of the denser medium. Now, what happens when the light strikes the rarer medium greater than its critical angle? That means here it is the rarer medium and it is the denser medium. Now when the light strikes at critical angle, then after refraction the refracted ray goes like that. That means angle of refraction is 90 degree. Now, if the angle of incident is greater than theta c, that means a red light, then what happens? Then the total incident light gets reflected to the denser medium, and this phenomenon is known as total internal reflection. When a light rays from denser medium strikes the rarer medium at an angle greater than the critical angle for those two medium, the ray of light is reflected back to the denser medium obeying the laws of reflection. It is known as the total internal reflection. Here the two conditions are there. Must be light travels from the denser to rarer medium, and the angle of incident must be greater than the critical angle. Here the reflection takes place according to the laws of reflection. That means it maintains all the two laws of the reflection. Now here the use of total reflecting prism. A right angled isosceles prism must be, it will be right angle isosceles prism of glass having polished faces is called the total internal or total reflecting prism. We know that the angle between the glass and critical angle between the glass and air is nearly 42 degree. Now this is the total reflecting prism. When the light ray falls on that surface perpendicularly, so it gets from air to glass, then it goes straight according to the laws of refraction and strikes the hypotenuse at an angle of 45 degree. Because this angle is 45 degree, this angle is 45 degree, and this is 90 degree, geometrically this is 45 degree, so it will be 45 degree. So the light strikes the hypotenuse at 45 degree, which is more than the 42 degree. So the light does not refracted, it gets total internal reflection and strikes this side perpendicularly, and again it refracted and comes out from the prism. Now here, this is here the hypotenuse, the light ray strikes the hypotenuse perpendicularly, so it travels perpendicularly, refracted perpendicularly and strikes this side. If you calculate, then also you get here the light travels strikes this side at 45 degree. That means angle of incident is more than the critical angle of the glass. So the light ray gets total internal reflection and it reflection and strikes this side at again at 45 degree. Just you can prove it by simple geometry. When it strikes this side at 45 degree, again it is the more than the critical angle of glass. So here also the total internal reflection takes place, and then it strikes the hypotenuse perpendicularly and get refracted and comes out from the prism. Also here this is the light ray and it travels this and it goes and strikes the hypotenuse more than 45 degree, so the total internal reflection takes place and it comes out like that. So here the total internal reflection takes place when the light travels through the total reflecting prism. Here the when the light strikes here, so and it goes there, so the deviation of light is 90 degree. Here the light strikes here and it comes here, so they are parallel but opposite in direction, so the light deviated at 45 degree. Here light, incident light is there and it is the emergent light, both are parallel and in the same direction, so the deviation is 0 degree. This is the total internal reflection and total reflecting prism. Thank you.